Okay, time to move on. I've chosen some of the problems I assigned to you from 6.5 using the law of sines. Hopefully, this will clear up most of your questions. So for number 9, just says solve the triangle. So that means we're going to find all of the missing measurements. They've given us two angles, they've given us the length of one side. We should be able to find the other three pieces of information, starting with, rather simply, the angles should have a sum of 180 degrees. If I take the 46 and the 20 and add those together, I believe I get 66 degrees. Subtract those, that'll give me a difference of 114. And that's exactly where I need to start because that's the measure of angle C. I need to know the measure of angle C because it's the angle opposite the one and only given side length. So now I can set up proportions here and say that the sine of 114 degrees divided by 65 is going to be one side of the proportions I need to solve for the other missing segments. Say I do something crazy like start with angle A. So that's the sine of the 46 degrees divided by the length of side A. And then I'm going to use that same ratio in the other proportion here, taking the sine of 20 degrees to find the length of side B. So again, they're going to be solved in very similar fashions here. We can do the cross product, and then this will be A times the sine of 114 is equal to 65 times the sine of 46 degrees. But then I'll have to divide to get the length of side A by itself. Time for the calculator. Would it surprise you that I have students in the past who have gotten so used to their favorite trigonometric ratio that they try and use cosine for something that's called the law of sines? No, that wouldn't surprise you people at all, would it? Don't think the directions were all that demanding. So let's say to the nearest tenth, we would round that off to about 51.2. And again, it's a side length that doesn't have a particular measurement there, so we don't have to worry about that. And again, similar process over here. We find our cross product. The length of side B will be equal to 65 times the sine of 20 degrees divided by the sine of 114. And we'll round that off to about 24.3. Now again, a quick check here to make sure all of this is consistent. So we're saying this angle is 114 degrees, extremely obtuse. 114 is the largest angle, so the 65 should turn out to be the longest side. For side A, we're saying 51.2. For side B, we're saying 24.3. And yes, that's completely consistent here. The shortest side is opposite from the smallest angle. The longest side is opposite from the largest angle, and medium match up. Okay. Now, again, it's a proportion here based on the sine of those angles. Don't get too hung up on 114 is much bigger than 46, Mr. Mark. This is 65. Shouldn't that 50? No, the 51.2 is accurate. It's not a proportion here based on the angle measures themselves. It's a proportion based on the sine of those angle measures. And we've talked about this before, that sine has to be something between +1 and -1. All right, for the next section, they asked you to, just sketch the triangle, solve it using the law of sines. Now, again, the picture does not have to, I really don't want to take the time for this thing to be hyper accurate. The picture is going to help us get there. The picture is not the answer. I know it's triangle ABC because they called this third side side C. So angle A is 50 degrees, angle B is 68 degrees. Went a little bit too far. Now again, they call this side C, so that is the side opposite from angle C, has a length of 230. 230 watts, doesn't matter. Substitute your favorite measurement. What we do need to do, and it does matter, is find the measure of angle C. Again, we know the sum of all three is equal to 180. 50 and 68, I believe, is 118 degrees. So that'll leave us with a difference of 62 degrees. So that's the measure of angle C, and that's absolutely necessary as we're setting up and solving the triangle to find the missing side lengths. So we will say that sine of 62 degrees divided by 230 is the same proportion to find the length of side A. We'll take sine of 50 divided by side A. To find the length of side B, we'll take the sine of 68 divided by B. Now again, just a moment's consideration here, what those angle measures are telling us. The 230 is going to be the medium side. Side B has to be longer. It's opposite a larger angle. Side A has to be shorter. It's opposite a smaller angle. So 230 times the sine of 50 degrees divided by the sine of 62 will give us, I guess we should tenths place, round that off to 199.5. And again, if this is side A, we were predicting shorter than 230. Sure, it's even shorter than 200. And then for side B, I guess we'll round that off to 241.5. And again, that's the longest side bigger than 230. So please again check and make sure from a logical standpoint things are consistent here with your triangle. Number 19, use the law of sines to solve for, they've changed the directions, all possible triangles that satisfy the given conditions. Well, what does that mean? If we go back to the given information in 13, this is angle side angle. There's no doubt angle side angle makes one triangle. We have an angle side angle congruence theorem in geometry. So that's why here I'm only worried about one set of answers. Here for number 19, I'm given the length of side A, the length of side B, and the measure of angle A. Oh, that's obtuse. Maybe I'll try and put that in as I'm sketching the picture here. I'm going to call this angle A, B, C. So now side A is 28. Side B, opposite from angle B, is 15. And it's the measure of angle A, that's 110 degrees. Law of sines, well, all right, let's try and find the measure of angle B because we know the length of side B. So I could say that the sine of angle B divided by 15 is equal to the sine of 110 degrees divided by the length of side B, which is 28. We don't have to worry too much about a cross product this time. Just get rid of that denominator, multiply both sides by 15. This will tell us the sine of angle B. What does that number tell us? It tells us the sine of angle B. This is not the measure of angle B. We're not saying that that angle is, what, half a degree? No, absolutely not. So our next step here then is to take the inverse sine of both sides to get that angle measure. We want inverse sine of that answer in degrees, and we'll round that off to about 30.2. Now, again, if you remember the examples that I went through, you go through, you use the law of sines, you take the inverse sine to get an angle, and then you have to determine if you have just one solution, or maybe two solutions, or maybe no solutions at all. And the way I described that was once you take the inverse sine for this angle, then what we'll normally do is find the supplement to that. Well, the supplement to 130.2 degrees would be, let's see, 180 minus 30 should give you 150. So this is 149.8. Hold on. We already have one obtuse angle. We can't have another one. This tells us we only get one solution here. Oh, isn't that nice? So now if we're saying the measure of angle B is 30.2 degrees, now that we have 2 out of 3 of them, then we can find the measure of angle C. 110 plus 30.2, I believe, should be 140.2. Subtract that from 180. And then the measure of angle C, we're left with, oh, come on. So we've got to go boom, boom, boom. 39.8 degrees. And once we know that, then we can go across and find the measure of side C. Always, I can't overemphasize this, always go back to the given ratio. God forbid I pushed a wrong button here and got something messed up. If I use an inaccurate number to do my next calculation, what are the chances that two wrongs make a right? So again, do our lovely cross product. So it appears the length of side C, I guess we'd round that off to about 19.1. Is it consistent? Well, sure, then the 30.2 degree measure of angle B is the smallest angle, so side B of the 15 has to be the shortest side. Side C then has to be the median, so somewhere between 28 and 15, and 19.1 certainly works. For 21. Again, angle A is obtuse, so I'm going to try and incorporate that into my picture here. So here's A, B, C. This angle, 125. The measure of angle A, I'm sorry, the length of side A is 20. The measure of side C is 45. Do you see something wrong right now? Okay, if not, that's okay. I think it'll become fairly apparent here in just a moment. So if I use the law of sines, the sine of 125 degrees divided by the length of 20, side opposite, I know this is side C, so I'll set this up using the sine of angle C divided by 45. Now again, just multiply by 45. So we get the sine of angle C is 45 times the sine of 125 degrees divided by 20. If there are no bells and whistles going off in your head yet, again, this is telling us what the sine of the angle is. So then to find the angle measure with our calculator, we'll use the inverse sine of that value. And sorry, thanks for playing. We have some lovely parting gifts. It's undefined. There's no angle where the sine is greater than 1. Which means what? That's our answer. The picture didn't match up with common sense. Angle A, being obtuse, has to be the biggest angle. which means the side opposite, side A, has to be the longest side. But then we've got side C that's longer than the longest. No, that doesn't work. But again, if you saw that at the start, that's great. Good for you. If you didn't, here's evidence. Okay? Please don't just blindly go through. If you didn't see it at the picture, hopefully you saw it at that step. Before we even take the inverse sine, I've got something greater than 1. That's not possible. $23. All right, now we've got angle B is rather small. Not sure exactly what's going on here. So here's A, here's B, here's C. Side B is 25, so again, that's opposite from angle B. Side C, opposite from angle C, that's 30, and the measure of angle B is 25. Well, that's a little bit too big, but meh. Well, isn't that nice? The 25s match up. That hopefully won't be too tough here. So I could say the sine of 25 degrees divided by the length of side B, which is 25, is equal to the sine of angle C divided by, they gave me the length of side C is 30. Multiply both sides by 30. That's our value for the sine of angle C. All right, it's reasonable. It's less than 1. So we can then take the inverse sine of that value. Okay, that seems reasonable, about 30.5 degrees. So we could say the measure of angle C is approximately 30.5 degrees. Now if we go back, I think I went back too far. Yes, I'm sorry, for number 19. That one angle that we were given was obtuse. We did the inverse sine and found, again, the principal value here is always going to be, through your calculator, something that's in quadrant number 1. We have to consider that it could be acute or it could be obtuse, because second quadrant, where you're going to find obtuse angles, sine is also positive. But for number 19, the first angle was obtuse. There's no way that we were going to get another answer here with an obtuse angle. One solution. For number 23, the given angle is acute. Our calculator is always going to give us an acute angle. We have to consider that angle C might be obtuse. That would be consistent that the 30 is bigger than the 25. Angle C has to be bigger than angle B. We have to consider the possibility that angle C might be acute or it might be obtuse. Well, how are we going to do that? Find the supplement. $149.5. Is that too big? No, if we take the 149.5 and we add 25 to that, that'll give us a total of, I'm sorry, let me get rid of you. 174.5. There's not a lot of room left, but yes, there is room left. So we could say then that the measure of angle A is a measly 5.5 degrees. So we could get this and this as the two missing angle measures. So that means we have two solutions here. Let me finish out this one here by saying then we can use law of sines. So the sine of 25 degrees over the length 25. Now I'm looking for the length of side A. So that's the sine of the very small 5.5 degrees. Side A is going to be very short. It's opposite from a very small angle compared to the 25 and the 30. So again, we do our lovely cross product there, solve for A. So about 5.7. So side A is about 5.7. Which would definitely make it the shortest side compared to the 25 and the 30. But now we've got to go back for our other set of answers. That again, if A is what we're missing, 25 was given, 30.5, that's our principal value from the calculator there. Those have a sum of 55.5. In this case, it's angle A that would be obtuse. And I just forgot what it said, 24.5. Which means in this case, side A is going to be the longest side. Okay, so again, notice here it's a very similar calculation. That I did earlier with the really small angle gave us a very short side A. Now that we're doing this again with an obtuse angle, we're getting a very much longer side A at about 48.8. Whoops, forgot that one. So there's the whole set. Here we got one solution. Here we got no solutions. And here we get two sets of solutions. Remember, it says solve the triangle. They're going to give you three measurements. You have to provide the other three measurements. Well, in this case, two possibilities. It's a total of 6 answers. All right, how'd you do with the drawing? Oh, please don't tell me that you took the time to go and Google this. We know what the Leaning Tower of Pisa looks like, right? Hopefully, maybe, possibly, you learned something there with that very first sentence. It's constructed right next to a cathedral. It was designed to be the bell tower. And once they put those tremendously heavy bells up at the top of it, that's when they realized, hey, maybe we shouldn't have built this on a dry lake bed because it's not very stable. It looked really flat, and boy, were we wrong. From the vertical, these days, it leans over at about a 5.6 degree angle. Now, I really don't think that that's accurate. But the picture is supposed to just help us here. We have then, let's see, I guess this is the base, and then we have a turista over here. Standing 105 meters from the base, the tower leaning directly toward her. She measures the angle of elevation to the top of the tower. Okay, so again, we know angle of elevation has to start from the horizontal and go up to the top of the tower. This is our angle of elevation here at 29.2 degrees. Find the length of the tower to the nearest meter. Well, okay, the length of the tower would be this side of a, whoa, it's not quite a right triangle anymore. However, again, let's put one more piece of information in here. If we're measuring it from the vertical, saying that it leans over that much, let's say X marks the spot here so that we can be more precise. The measure of angle XBT would have to be the complement of that 5.6 degree given angle. Let's get that out of the way. So we could say that this has to be 84.4 degrees to give us angles that are complementary. Well, that still doesn't give us what we need here. Oh, all right. How about angle X now? We've figured out this is 84.4. Angle of elevation was given to us there at 29.2. So then we should be able to, yeah, subtract from 180. This angle is 66.4 degrees. And now that we have things paired up with the length of one side and the measure of the opposite angle, now we can set things up using our law of sines. So the sine of the 66.4 degree angle divided by that distance of 105 should be proportional to the sine of 29.2 degrees divided by the length of the tower itself. Again, find our cross product here. So we're going to take 105 times the sine of 29.2 degrees divided by the sine of 66.4 degrees. And again, if we want to round that off to something reasonable here, that's about 55.9. Now, in this case, they did give us units of measurement, so make sure that's part of your answer. This distance here was 105 meters, so this should be 55.9 meters. Everybody's favorite, 39, the height of the tree. Tree on a hillside casts a shadow 215 feet down the hill. If the angle of inclination of the hillside is 22, the angle of elevation to the sun is 52, how tall is the tree? I say we need a better picture. So we know this distance is 215. And we're shown here in the picture that The hillside is slanted at a 22-degree angle. Angle of elevation up to the sun is 52, which means, okay, 52 minus 22, that's a 30-degree angle. If we extend the tree trunk all the way on down to the horizontal here, and look at this big right triangle from here to there to here. If this is 90 degrees and that's 52, then this angle up here has to be the complement of 52. That's got to be 38 degrees. That's the angle that we need because we know the side opposite is 215. We always have to match up the length of one side and the measure of the opposite angle. So now that we have that, law of sines, sine of 38 degrees divided by the 215 should be equal to the height of the tree opposite the 30. So sine of 30 degrees divided by h. So h is 215 times the sine of 30 degrees divided by the sine of 38 degrees. Again, the key thing here is finding that angle that's opposite from the given side length. Okay, and again, just by extending a couple of those lines, we should be able to find that. They gave us the shadow length here to the nearest foot, so I would argue we should round that to the nearest foot. Okay, I hope that helped. Well, especially with the tree problem. Again, if you have any additional questions that I did not go through in this video, please mark them and we'll talk sometime soon.